by drawing a really weird looking cell. I know it's weird looking because it's going to be like the wrong shape or like size of stuff, but that's okay. What organelle did I just draw?
Mitochondria.
Mitochondria, good. All right, what's the very first process or step in cellular respiration? What's the very first thing that happens in cellular respiration? Anyone remember? Glycolysis, good. Glycolysis. And where in my cycle here, where in my cell is glycolysis going to happen? In the cytoplasm. All right, so I'm going to start here with glycolysis. And we'll come back to this diagram. We'll just keep referring back to it. So glycolysis. What does the word glycolysis mean? Splitting sugar. Glyco, sugar, lysis, split. So the term glycolysis literally means to split sugar. Okay, and we already said that this happens in the cytoplasm. Alright, where'd my green go? Alright, so what's the very first thing that has to be input to start the process of glycolysis? What do we need present? Glucose, good. So we're going to start out with a glucose molecule. And glucose has how many carbons? 6. I'm just going to keep like that circle. I know glucose is really like a ring structure, but we're just going to do that just to count the carbons. And glucose is going to be split, based on the name, into what? What does glucose split into? 2 pyruvates. Okay. How many carbons is our pyruvate molecule? 3. So did we lose any carbon in this process?
No.
Nope. Nope. All right, good. So to initiate this reaction, to go from glucose to pyruvate, what is required? What do we need to start or to initiate this reaction? Yeah, ATP. ATP. So I need to put 2 ATP into this equation. And what comes out? ADP and inorganic phosphate, right? That inorganic phosphate is actually going to be part of that pyruvate molecule. But I should have told you guys, sorry. I'm going to summarize, and this is like true summary, what you have to know. I am not going through the chemistry of everything today. If you are a chemistry person and you need to see where these molecules are moving and how the carbons are moving and what's being added at each step of the way, look at your textbook. Your textbook has all of that. You will not be required to know that for the AP test, but I know for some of you that's how your brains work and that's going to help you. So if you need to actually see that movement, I'm more of a magic person, so I'm just going to memorize. It requires 2 ATP and 4 ATP come out. And I'm not going to follow through what's happening on that molecular level the whole time. So, glucose. Glucose is going to be oxidized in this, right? We talked about how it's a series of redox reactions. So if glucose is oxidized, what does that mean?
Oxygen is added.
For oxidizing it, is it gaining or losing electrons? Losing electrons. It's donating electrons to somewhere. What molecule would maybe want to receive electrons? What molecule have we been talking about in this process that is an electron acceptor? NAD+. Good. NAD+ is going to accept those electrons and be reduced to NADH. We're actually going to have 2 of these in this process. Okay. We also are going to make ATP. So what is required in order to make ATP? ADP and inorganic phosphate. Okay, so now let's look at the net production of what we get from this reaction. If I'm looking at the net production here per glucose, I started out with glucose, right? And glucose, what did I get from that? How many pyruvates? Two. Okay. How many ATPs did I get per glucose? Net per glucose in the process of glycolysis. How many glucose molecules did I get? Or ATP molecules, sorry. How many ATP molecules did I get? Two. Why are we saying 2 instead of 4? Because 2 are required to start it, and I'm asking for net, right? So I'm going to put 2 ATP. And how many NADH? 2 NADH. Okay, so in glycolysis, this is what is produced. So you need to know what goes in and what comes out of all these reactions and where it's going to. So where is my pyruvate? Where is that going? It's going to go into the mitochondria, and it's going to go to the link reaction. Good. So this is on its way to the link reaction. Where's my ATP going to go? Where's that ATP going to go? To what?
Out of the cell.
It's going to be used by the cell, right? Because your cell just needs ATP for energy, and so it's just going to be used by the cell. Okay? And then, what about the NADH? Where's that NADH going to go? It has extra electrons, right? Where do you think it would go? We saw this on Friday in our activity. Where does that want to go to what step is it going to go to? Does anyone remember? Yeah, it's the last step of cellular respiration. Anyone remember what it's called? Not the Krebs, it's after the Krebs.
Oh.
Oxidative phosphorylation, yes. Also known as the ETC, or the electron transport chain. So I'm going to use the electron transport chain here. Or the ETC. And we'll look at that when we get to that part. So now let's come back over to our diagram over here. And how many ATP were produced in glycolysis? How many ATP were produced? 2. So I'm going to get 2 ATP from this process. What is going to move on to the next step of my reaction? Pyruvate. Moves on to that next step of my reaction. And we just said that NADH, we had 2 NADH, and they are going on to the electron transport chain. So we'll just leave them there for now, and we'll connect that at the end. Any questions on glycolysis? Anything that I can answer on glycolysis? No? Okay, let's move on to the next step then, which is known as our link reaction. Does anyone know, what does your textbook call this reaction? Not the link.
Citric
called,
acid cycle?
nope, not the citric acid, before that. Pyruvate oxidation. Okay, pyruvate oxidation. What's going to happen during that step? What's going to happen to my pyruvate molecule? It's going to gain or lose electrons? It's going to donate electrons or lose electrons. Okay, good. Where in my diagram, where do you think that the pyruvate oxidation or link reaction happens? Inside the mitochondria. Good. So let's actually just box these. That will help. Okay. So the link of the pyruvate oxidation, and this happens in the inner mitochondria. All right. So what am I going to start with? What do I need to start this reaction? What's my input
Pyruvate.
from the last reaction? Pyruvate. And in this process, pyruvate is going to be oxidized. Okay? Pyruvate has how many carbons? 3. Good. We're going to actually lose a carbon in this process. And when we lose a carbon, what form do we lose carbon in? CO2. Good. So we're going to lose a CO2, and that's 1 carbon. Oh, that's kind of confusing. So how many is my end molecule going to have? How many carbons? 2. And this end molecule is called acetyl. Okay. Now we said that this is called pyruvate oxidation. Now, thinking about what happened during oxidation here, where glucose was oxidized, what do you think is going to happen in this reaction? Yeah, we're going to go from NAD plus to NADH. That is a reduction reaction from the oxidation of pyruvate, right? And so that is what we're talking about with that oxidation. Good. Now, in this process, is any ATP made? No. Nope. But it's a little bit, we're missing one piece of it. What has to enter into this yet to make my final molecule? Does anyone remember what goes into the Krebs cycle? Coenzyme A. Good. So I need to add CoA into this equation. And so then I end up with acetyl-CoA at the end. So once again, we can do our net per glucose here. And if I go with my net per glucose, I started out with how many pyruvates per glucose? 2, right? 2 per glucose. So I'm going to have 2 pyruvates. And in the end, how many acetyl-CoAs will I have? 2. Good. What else am I going to have per glucose? How many NADHs will I have per glucose? How many NADHs per glucose? How many NADHs did I get per pyruvate? 1, right? And I have 2 pyruvates. So how many NADHs will I get per glucose? 2. How many CO2s will be produced per glucose? Yeah. In this reaction, we only get 1 NADH instead of 2, so that's why. Yeah, good question. How many CO2s will I get? 2 per glucose. Good. Excellent. So now, where is my acetyl-CoA going to go? Where is this going to, acetyl-CoA? It's going to the Krebs cycle. Good. Okay. Where's the NADH going to go? To the ETC. And where's the CO2 going to go? What happens to CO2 in your body? It gets exhaled. Good. Okay. And so now our acetyl-CoA is ready to move on to our next stage. So let's go summarize that over here. Were any ATP produced in the link reaction? No. What moved on to my next cycle?
Acetyl-CoA.
Acetyl-CoA moved on to what we're going to call the Krebs. Did I have any NADH form or produced from this? Yes. So I'm going to, how many NADHs?
2.
Okay, I'm just going to bring those over for now. We'll connect those. Any questions on glycolysis or pyruvate oxidation? Any questions on anything that's on the board so far? If you want to take a picture now. I'm going to erase these from here on and then start over. So if you want to take a picture, do that right now. Okay? While I take a few more bites of my lunch. We okay?